We're going to do some FOIL today. That's expanding brackets, or actually executing when a binomial is squared or cubed or power 4, etc. And once we see how horrendous that gets once you get past power 3, power 4, power 5, we're going to talk about a thing called Pascal's triangle and how it can make this process a whole lot easier. So first off, I've got an example here, x plus 3 squared. When you have anything squared, that means you take that thing and you multiply it by itself. Now with a normal number, right, 5 times 5 is 25, you can just multiply it, no problem. But when you have a binomial, you have to take everything in this bracket and multiply it by everything in that bracket. So you have to come up with all the combinations of something from here and something from here. So if you start with the x and the x, you get x times x. This x with that 3 will give you 3x. Now there's no one else I can partner this x with. I've partnered it with this, I partnered it with that. And I'm going to sort of show you that I've done that by drawing some lines over top. So I put x with x, I got this. Put x with plus 3, and I got this. So everyone in here has been multiplied by x. To finish, I have to multiply everyone in here by 3. So 3 times x would be another 3x. And a 3 times a 3 would give me a 9. All right. So if I simplify that, I have x times x is x squared. 3x and 3x is 6x. And plus 9. Got that back. Okay, so that's how you multiply binomials. Where this FOIL thing comes from. If you notice, I took the first two things in each binomial first two. Then I did this multiplied by this, which were the ones on the outside of the multiplication. It's the outside 2. Then I did this multiplied by that, which was the inside 2. And then I did the last 2 in each binomial, the 3 multiplied by the 3, which gives me the last. Okay, so that spells F-O-I-L, FOIL. So when you see that word in this context, it means that you are expanding a binomial by making all the proper combinations. You don't have to do them in this order. It's just a spellable acronym, a pronounceable acronym that will let you figure out which combinations you need to make sure you don't miss any. Okay, so that's what it would look like if you had x plus 3 squared. If I try to do x plus 3 cubed, that means x plus 3 multiplied by x plus 3 multiplied by x plus 3. So I need all the combinations of taking something from here and here and here. Well, here we go. I could take the x with the x with the x. I could take an x and an x and a 3. I could take an x and a 3 and a 3. I could take, well, that's it. If I am forced to take this x, I could either take an x and an x and x and a 3, 3 and a 3. Oh, or I could take a 3 and an x. You know what? Let's just not do this. This is too complicated. Let's try this FOIL thing. I know this much is this. So x plus 3 would be x squared plus 6x plus 9. So to do this, you're going to have to do all this work, get your answer, and then do x with an x squared is an x cubed, and x with a 6x is a 6x squared, and x with a 9 is a 9x. A 3 with an x squared is a 3x squared. A 3 with a 6 is an 18x, and a 3 with a 9 is a 27. Now I stacked them that way because I can see which terms I can gather then. This gives me x cubed plus 9x squared plus 27x plus 27. Okay, now let's imagine for a minute we were doing x plus 4, or sorry, x plus 3 to the power 4. Oh, forget power 4, let's do power 6. So that might happen to you. X plus 3 to the power 6 is the same as x plus 3 cubed times x plus 3 cubed. The cube times the cube is a 6th. That means I'm going to have to take this whole thing and multiply it by itself. I don't think we're going to be able to finish this one. I'm going to have to put an x cubed with an x cubed. That's an x to the 6. An x cubed with a 9x squared, which is a 9x5. X cubed with a 27x, which is 27x to the 4. X cubed was a 27, it's 27x cubed. And I'm going to have to put a 9x squared with an x cubed, it's 9x to the 5, a 9x squared to 27. Oh god, 9 times 27 is 180, plus 63 is 243. X cubed, I was doing this one, x to the 4. I'm going to have to put, I just put this with this, that generated 4 terms, and then this generates another 4 terms, and this generates another 4 terms, and this generates another 4 terms. I'm going to have to do 16 multiplications here in order to get this done. And you notice that I'm getting some x to the 5s here, and some x to the 5s here. There'll be some x to the 5s that I haven't done yet. You have to gather all those terms together, and it's going to be gross. So there has to be a better way. Because all of these numbers, right, like 9, 27, 27, this is 3 squared and this is 3 cubed. So those numbers have to be coming from 3 somehow. So there must be a way I can just shortcut. So I'm going to get this off of here and I'm going to clean out the FOIL thing. And we're going to try expanding just x plus 1, because it's going to keep the numbers down. X plus 1 squared will be x plus 1 times x plus 1. An x and an x is x squared, an x and a 1 and an x, and a 1 times a 1 gives me this. All right, and then I'm going to try x plus 1 squared, or cubed, sorry. That would be x plus 1 times x plus 1 times x plus 1, which is just x plus 1 times x squared plus 2x plus 1, because we already did 2 together and got this. An x and an x squared gives me an x cubed. An x and a 2x gives me 2x squared. An x and a 1 gives me 1x. 1 and an x squared gives me 1x squared. So I'm going to stack those so I can see my similar terms. 1 and a 2x is 2x, and the 1 and the 1 is a 1. Give me a total of x cubed plus 3x squared plus 3x's plus 1. There's 2 of these and 1 of these is 3 of them. 1 of them and 2 of them is 3 of them. There we go. I'm going to try x plus 1 to the power 4. That's x plus 1, x plus 1, x plus 1, x plus 1. Turned into a 4 there. But that, again, that's just going to be x plus 1 multiplied by this, because we've already done 3 of them together. All right. So an x with an x cubed is an x to the 4. An x with a 3x squared is a 3x cubed. An x with a 3x is a 3x squared. And an x with a 1 is an x. Now, plus 1 with an x cubed would be plus 1x cubed. A 1 with a 3 would be 3x squared. A 1 with a 3x is 3x. And a 1 with a 1 is a 1. Which gives me x to the 4. 3x cubed and 1x cubed is 4x cubed. 3x squared and 3x squared is 6x squared. 1x and 3x is 4x. And got a plus 1 in the back. Okay. So I could keep going, but I think we've got enough here to establish a pattern. I'm going to add to my little diagram here that x plus 1 to the 1 would be 1x plus 1. And I'm going to add to my chart here that x plus 1 to the exponent 0. Well, anything to the exponent 0 is 1. I'm going to get rid of this work here. I'm going to put in my final answer, 1x squared plus 2x plus 1. And I'm going to get rid of all the work here. I'm going to put in my final answer, that x plus 1 cubed was x cubed plus 3x squared plus 3x plus 1. And I'm going to get rid of all this work here. Put in my final answer, x to the 4 plus 4x cubed plus 6x squared plus 4x plus 1. And I'm going to clean out all this stuff so I have some space to work. So we've done some FOIL stuff, that's good. Now we're on to the Pascal's triangle part. So Pascal's triangle is just a little number pattern. And the idea is you start with 1, 1, 1 in a triangle, like that. If you want to add a row to the triangle, you add a 1 at the end and a 1 at the beginning. And any space that's between two numbers, like right here, you get the number there by adding those two together. So 1 plus 1 is 2. There's kind of some arrows here. Those two numbers made that. Now, if I made another row, start with a 1, end with a 1. This 1 and this 2 would make a 3. This 2 and this 1 would make a 3. And if I were to add another row, start with a 1, end with a 1. This 1 and this 3 make a 4. This 3 and this 3 make a 6. This 3 and this 1 make a 4. I'm going to let you look over there at the polynomials we generated with FOIL, and you're going to think about how much work those were. And you're going to look at this triangle, and hopefully what you're seeing is I've got a 1, 1. I have a 1 and a 1, a 1 and a 1. I have 1, 2, 1, 1, 2, 1, 1, 3, 3, 1, 1, 3, 3, 1, 1, 4, 6, 4, 1, 1, 4, 6, 4, 1. This isn't an accident. These numbers are from combinatorics, right? If you have 4 objects available and you need to pick 2 of them, there's 6 ways to do that. Until you get into stats and things, that won't make any sense to you. But if you can think about generating this bracket, I had 4 choices to make, right? Either X or 1 from the first bracket, either X or 1 from the second bracket, either X or 1 from the third bracket, either X or 1 from the fourth bracket. So I had to make 4 choices. So I'm choosing 4 here. Choosing from 4. So those numbers about the combinatorics ideas are the number of ways you could combine 2 X's and 2 1's in this particular term. And it turns out you can do that 6 ways. How many ways can you combine 3 X's and a 1? Well, if you have 3 X's and a 1, you could do 1x, x, x, or you could do x, 1, x, x, or x, x, 1, x, or x, 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 1. Right? There's 4 ways you can do that. So that's why that number showed up there. But again, you don't need to stress about why it works. If you just take a moment to appreciate how you can use it, I'm about to try and do x plus 1 to the power 5. Now, I would normally have to write x plus 1, and then I'd have to write this whole thing, and I'd have to do x multiplied by all of those bits, which is going to generate 1, 2, 3, 4, 5 terms. It's 5 multiplications. Then I'm going to have to multiply by 1 5 times. That generates 10 terms in total. I'm going to have to collapse down based on like terms. It takes a long time. But if you notice the patterns here, I had just a number, then an x and a number, then an x squared, an x and a number, an x cubed, an x squared, an x and a number, an x4, an x cubed, an x2, an x and a number. So this one is going to have an x to the 5, an x to the 4, an x to the 3, an x to the 2, an x, and then just a number. It has to do that by the pattern. The only thing I don't know is what these numbers are. But if I have Pascal's triangle already built, I can start with a 1, end with a 1. 1 and 4 make 5. 4 and 6 make 10. 6 and 4 make 10. 4 and 1 make 5. So there are my numbers. 1 here, 5 here, 10 here, 10 here, 5 here, and the 1 at the back. And I didn't have to do any FOIL. I could just write her out. So you can keep adding rows to your triangle. And the handy thing about this is once you generate it once, it just sticks around because this isn't dependent on anything. This is just the pattern. So 1, 7, 21, 35, 35, 21, 7, 1. So you get this on a study sheet or a poster on your wall, and you just keep it around forever, and you don't have to ever generate it again. But you do now have all of the coefficients that you need to stick onto an expansion. So if you wanted to do x plus 1 to the 7, and you hadn't done any of this work before, you're going to have to start with this. foil this into this, foil that into that, foil that into that, foil this into this, foil that into the answer of that, foil this mess into the answer of that. Ugh, I don't want to do that. Instead, I'm going to know that this Pascal pattern exists. It'll be 1x to the 7 plus 7x to the 6 plus 21x to the 5 plus 35x to the 4 plus 35x to the 3 plus 21x to the 2 plus 7x to the 1 plus 1. It took as long for me to answer that question using Pascals as it took for me to set up the question using FOIL, and let alone do it. So this is gold, right? So FOIL plus Pascal's triangle equals a happier you, because now you don't have to do all that FOIL stuff. So how do you handle this if it's not a 1? Because that's sort of sticky here. So I'm going to clear this off and we'll give that a try. I'm going to try and expand that, and I'm going to try and use Pascal's triangle to sort of figure out how to shortcut it. So x plus 5 is x plus 5 multiplied by itself, which gives you x with an x, a 5 with an x, a 5 with an x, and a 5 with a 5. Okay, so this thing, that's x squared there. This at the back, that's 5 squared. And in the middle here, you have two 5x's. Now, if you can see, you've got 1x squared, 2 5x, and 1 5 squared. There's that number, 1, 2, 1. If I try to do x plus 5 cubed, I have x plus 5 multiplied by this nonsense. And I know this is a bit awkward to look at, but if I set it up like this, we're going to be able to track where all the pieces land. So I'm going to expand this now, and the order in which I put the pieces might be a little bit weird, so bear with me. I'm going to have to put an x with an x squared. That makes an x cubed. Then I'm going to have to put an x with a 2 5x. So I'm going to keep the 2 up front, then I'm going to keep the 5, then I'm going to keep the x that I already had, and the extra x makes an x squared. So the 2 is accounted for, the 5 is accounted for, this x is here, that x is there. Next term, I have to put an x with a 5 squared. So I have a 5 squared with an x. So the 5 squared is there, the x is there. All right, next set of terms, I'm going to have to put a 5x squared, or 5 with an x squared, that goes here. I'm going to stack these 5s, an x squared. A 5 was a 2 times 5x, so there's going to be a 2. There's going to be a 5, but it's 5 squared, because 5 times 5 is 5 squared. And then this x is kicking around. So if you look for all the pieces, I've got 2, I've got 5, I've got x, and this 5 is there. Then I'm going to have to put a 5 with a 5 squared. That gives me a 5 cubed. So if I gather up my terms, I have an x cubed here. I have 2 5x squareds and an extra 5x squared. That gives me 3 5x squared. Now I have a 5 squared x here and 2 more 5 squared x's for a total of 3 5 squared x's. And I have a 5 cubed kicking around at the back. So I've got 1 of these, 3 of these, 3 of these, and 1 of these. There's my row from Pascal's triangle, 1, 3, 3, 1. Now I could finish this, right? I could do 3 times 5 squared, which would give me 75, and this would give me 125. I could do that. But I'm not quite after that right now. I want to talk about the pattern. Do you notice that it went x cubed, then x squared, then x, then no x at all? And do you notice coming from this direction, it was 5 cubed, then 5 squared, then 5, then no 5 at all? So if you were to have a list of descending powers of x from left to right, and a descending power of x of the number from right to left, you would have generated all the possible combinations of x and 5. And then you just need to tack the Pascal's triangle number in front. So just to try that, if you tried to do x plus 5 to the power 4, well, I need descending powers of x. So x to the 4, x to the 3, x to the 2, x to the 1, and then x to the none. You can put that in for completion. From the other end, from down here, we need descending powers of 5. So 5 to the 4, 5 cubed, 5 squared, 5 to the 1, 5 to the none. These are all added together. Now this x to the 0, might as well not write it. There are no x's there. This 0 power of 5, might as well not write it. Now I just need to fill in my Pascal numbers. So from the 4th row, that's here, 1, 4, 6, 4, 1. So that's my expansion. Put these in brackets. So if you actually were to do the numbers, x plus 5, 4 would be 1x to the 4. 4 times 5 is 20 x cubed. 6 times 5 squared, well, 5 squared is 25, and 25 times 6 is 150. 5 cubed is 125. 4 times 125 is 500. And 5 to the power 4 is 625. So not once did I use FOIL to do this x plus 5 to the 4 expansion. I just noted that I needed descending powers of x, descending powers of the number I'm adding, and then I need my Pascal numbers to fill it out. I'm going to clean this off. I'm going to try one with the negative. So I see a power 5 there. Because I see a power 5, I know I'm going to need descending powers of x from 5 down. Really should put this over here, shouldn't I? Get that out of here. Next, 0. From the other end, I'm going to need descending powers of not just 3, but negative 3. It's negative 3 to the power 4, negative 3 cubed, negative 3 squared, negative 3 power 1. Oh, I missed one. 4, 3, 2, 1. It's power 5. So that should be 5, 4, 3, 2. Negative 3 to the 1, negative 3 to the 0. I'm just not going to bother writing them. Then I'm going to need my Pascal numbers. So it's in the power 5, so I need the row with a 5 in it. Be 1 plus 5 plus 10 plus 10 plus 5 plus 1. And then you clean up the mess. So 1x to the 5 is x to the 5. I have a positive times a negative, that will be a negative answer, and 5 times 3 is 15. I have a positive times a negative, because it's a square there. So that's a positive result, right? Any even number of negatives gives you a positive. 3 squared is 9, 9 times 10 is 90. Let's do 3. I have a positive multiplied by 3 negatives in a row. 3 negatives would be odd, so there'll be a negative response. 3 times 3 times 3 is 27, times 10 is 270. I have a positive times 4 negatives in a row. Even number of negatives gives me a positive result. 3 to the power 4 is 81. 81 times 5. 5 times 8 is 40. It would be 405. A positive times 5 negatives in a row. Odd numbers of negatives give you a negative result. 3 to the power 5 is 243. So I'm done. No FOIL required. Even if you have a bracket with something in front, so 2x minus 3 to the power 4, I still need descending powers of this, and then descending powers of this. So if I set that up, I'm going to need a 2x to the power 4, a 2x to the power 3, a 2x to the power 2, a 2x to the power 1, and a 2x to the power 0. It's on my forehead now. I will need descending powers of negative 3 starting on this end. Negative 3 to the power 4, negative 3 to the power 3, negative 3 to the power 2, negative 3 to the power 1, and negative 3 to the power 0. Might as well get rid of these 0 power terms because they don't do anything anyway. Maybe that will get it off of my forehead. And to that mess, I'm going to have to add my Pascal triangle numbers. So I need the row that starts with a 4. That's here. 1 and 4 and 6 and 4 and 1. Oh, we just got some mess to clean up. This is 2 to the power 4 and an x to the power 4. This is 4 times negative 3 times 2 cubed, x cubed. This is 6 times negative 3 is squared is 9 times 2 squared, x squared. I'm just applying the exponent laws to these brackets here. And 4 negative 3 times, or to the negative 3 cubed is negative 27. I have 2 to the 1 and an x. And back here, negative 3 to the power 4 is 81. Okay. 2 to the power 4, that's 2 times 2 times 2 times 2. It gives me 16. X to the 4. 2 cubed is 8. 8 times negative 3 would be negative 24. And negative 24 times 4 would be negative 96. At some point, you should feel free to use a calculator. I'm probably going to abandon my mental math in a minute because I'm not sure I trust it at this point. 6 times 9 is 54. 54 times 2 squared, well, 2 squared is 4. So 54 times 4 would be 216. Two times 4 is 8. 8 times negative 27 would be negative. 8 20s is 160. 8 7s is 56. 160 and 56 is 216 again. Not sure I feel good about that. 4 of these would be 80, would be 108. 108 times 2 is 216. Yeah, okay. Sure. Plus 81. Oh, I'm done. I've got all these things cleaned up. There are no similar terms to gather up. And I managed to pull that off without ever doing any FOIL. I just used this Pascal pattern. So when you get to doing calculus or advanced functions or math in general after that, there are a lot of terms like this where you have binomials to a power. And in order to make your life easier, learn this Pascal thing, because then you don't have to do FOIL, because foiling it all out just makes a big hot mess. But I think you're ready for the practice problems. There'll be some on there that are just with a +1 for you to get the hang of putting the pattern in. Then there'll be ones with a different number, ones with a negative, and then ones with a number